Greetings and welcome to week 4 of the Adult Learner. Our topic this week is organizing knowledge. Last week I mentioned during the warm-up video that there was a National Academy of Sciences volume called How People Learn, published in 2000, and that volume is actually listed in your syllabus as a free download and potential supplemental resource to your library. That study, as we brought it up last week because it endorsed our topic at the time regarding prior knowledge, including misconceptions, is one of the 3 pillars of learning that are critical for educators to know about. And another pillar from that same study is the necessity for deep understanding of the content and principles of the discipline that's being studied. And deep understanding requires the ability to organize new incoming knowledge, assimilate or accommodate it with what is already known so that it can be remembered, retrieved, and used. That's what learning is really all about. To draw the analogy from Winnie the Pooh's wisdom, we can't do anything with the knowledge we've taken in if we can't make sense of it. And a large part of sense making is seeing the connections between pieces of knowledge. Our objectives this week are to be able to describe the differences between how novices and experts organize knowledge. This is very important because we come to appreciate that learning and knowing things and using what we know is an expression of expertise. And so this ability to organize knowledge is an important part of the learning process. But it also has other implications for teaching because we sometimes lose track of the fact that we're experts and the people that we're teaching or training are less expert. They may even be novices. And we may sort of teach with expectations or assumptions about the nature of the learner that really aren't quite legit because we're forgetting that they aren't like us. Secondly, we'll want to know how to explain the relationship between knowledge organization and what it means to learn something deeply and understand it deeply. And we'll also show how that the organization of knowledge is related in part to certain elements that we can actually bring into our teaching or into our study of material. I just wanted to mention, since there is some, both in this presentation as well as in the chapter, about expertise and the development of learners, that we're only going to touch on that here because really developing expertise is much more engaged in chapter 4 of the Ambrose text. And we'll take that up next week. We might think of knowledge that we've learned as being the things we know that are encoded in memory and can be retrieved later on. And this cartoon implies a distinction between having information, just facts at our disposal, versus true learned knowledge. And that distinction is really the connections between the pieces of information. And the idea of connections in the learning process also has a neurological basis, where memory formation involves the construction of linking synapses between neurons in the brain. Memory of complex subjects requires making many neural connections. So part of what we want to understand after this week is how to make those bridging connections. How is the organization of information related to what the learner does and what the teacher does as well? I'm going to have you attempt some mental games during this warm-up video. And to get the most from these experiences, please be willing to play along with me and not just fast forward to the solution. So here's the first game. I want you to take just a few seconds here and learn this symbolic code system for representing numbers. Okay, now I want you to use that code to write this week's Monday starting date. No cheating by looking back. Okay, now perhaps you're saying, oh, come on, Gary, that was asking an awful lot. I'm very confused. I don't know how to do that. Or you might have even gotten angry that I had any expectation of you to. Remember, I wasn't grading you on it. But now let me take this a step farther. What if I told you to learn the symbolic code system for representing the numbers, the same table you just had, but now you also have the tic-tac-toe-like diagram on the right. Do you see now the relationship between the numbers and the symbols? how the shape of the lines that enclose the numbers in the tic-tac-toe board are a reflection of the coded symbol for each number. Okay, so now let's go through this exercise again. Use the code to write this week's starting date. And I'm guessing most of you that were successful at coming up with this relatively quickly. You were more likely successful this time around because you had more complete information to work from and you knew how the symbols were related to the numbers. By showing you the relationship, I was preparing you to undertake the translation task. Taking you through these steps sequentially is an example of employing what's called an advanced organizer for learning. Advanced organizers are any number of tools or cues that activate the brain appropriately for what is to come. An advanced organizer could just be something as simple as an outline or a flow chart of a lecture, for example. Even the objectives list at the beginning of each of the weekly modules in Learn is intended by me to be an advanced organizer for your learning. Your textbook has an advanced organization system that was described in the foreword, which I asked you to read back in the first week, and you've probably picked up on it as you've been reading each chapter. Each chapter begins with a pair of stories. These are concrete, relatable circumstances that may activate your own prior knowledge and experiences. Then there's a principle, which is somewhat more abstract, that tries to offer an explanation for those concrete stories. And then there are strategies, how to apply the principle in the practice of teaching. These advanced organizers, now that you know it, that's how each chapter of the text is laid out, gives you some idea of how to proceed, as well as the stories themselves essentially become a key part of the organization of the chapter by activating concrete ideas that you can easily relate to before having to try to digest the more complicated abstract principles that are developed farther on in the text. One could even imagine using this same sort of organization in a training session of stories, a principle, and strategies. You could start off by asking the students what they know or what the trainee's experience has been as a way of starting things out, or bringing your own stories to bear that help people realize, oh yeah, I can imagine that happening, or I've had that happen, and that is very much helps activate my brain to thinking about the sorts of things I need to think about during the training session. And then would come the actual content of the training to meet certain objectives. And in all trainings, we'd really want to have some clear, how do you do it, concrete practice opportunities. It's also worthwhile thinking about having learners organize knowledge to enhance their learning rather than you having to provide the advanced organizers all the time. This is an example of students drawing out a concept map on a whiteboard. A concept map, when we use the term appropriately, has a very specific meaning. It's not just a matter of drawing circles or boxes around terms and drawing lines and arrows to show connections between them. It's a bit more. It's really important that each of the connecting lines itself is associated with some sort of associated verbs or statements that elaborate the nature of the connection represented by that connecting line. These two characteristics, the concept and the labeled line connecting them, are what really define a concept map. Concept map is discussed a fair bit in your text for this week in Chapter 3. There's also an appendix, Appendix B, which includes more information on how to make a concept map that puts an emphasis on how these connections are put together in a concept map. So this is essentially a concept map describing concept maps. And although I'm not requiring it, I am encouraging you to think about coming up with a concept map or some other sort of organizational device in your 4R assignment this week as a way of sort of practicing this sort of knowledge organization tool. Here's another example of a concept map that outlines and summarizes an instructor's approach to his instructional design. And again, notice that the various elements of the curriculum are shown, and the connecting lines are not just show a connection, but use text to explain the nature of that connection. And there's some interesting color coding to show what the students are going to do in and out of class, and which connections he sees as being strongest and which ones are weaker. Another common organizer is a mind map, and having learners generate these is a little different. We've still got sort of nodes of information are connected by lines, but we don't use connecting phrases in a mind map. On the other hand, using digital tools to make mind maps, and there's several you can find online for free, you can actually add links to images and documents within the mind map. In my work at the med school, I've been encouraging faculty to have students use mind maps to organize the huge amounts of information they're bombarded with in their curriculum. This is an example which I found online of a med student's mind map of knowledge regarding rheumatoid arthritis. Notice the combination of illustration and text and the use of color to represent different things related to symptoms and treatments and so forth. I'd like to move on to another critical aspect of knowledge organization is the distinction between experts and novices. Experts are experts because they know how to organize information and are always improving their organizational frameworks, which also improves their memories. There have been quite a few studies of the differences in how novices and experts generate memories. The studies that involved the study of chess players. One of the very classic studies was conducted by William Chase and Herbert Simon back in the 70s, as referred to briefly in the Ambrose text, and I thought might be interesting to kind of illustrate with you. And so in a moment, I'm going to show you a view of a chessboard for a game that is already underway, and with 24 out of the original 32 pieces still in play. You will have 5 seconds to memorize the positions of each of those 24 pieces. Are you all ready? Here we go. Okay, so how many pieces from the previous image could you correctly locate on this board? This classic experiment was conducted more than 40 years ago by Chase and Simon. And when they ran the experiment with groups of chess players with different ratings of expertise, the results varied according to those expertise. The master players were able to place more of the locations into memory than were players with less expertise. And insights into how memories varied with expertise came from another experiment. In this second test, Chase and Simon used the same 24 chess pieces, but placed them randomly on the board rather than using the positions from an actual game. Now, the memories were indistinguishably poor regardless of the rated expertise of the chess players. We can explain these experimental outcomes by postulating that not only is knowledge retrieved better when the component elements are organized and connected, but the strongest and most easily retrieved memories are recovered in chunks of related knowledge. Returning to our cartoon, this could be the difference between trying to remember each dot on the left versus understanding relationships between the dots, such that we only need to know 4 chunks of information because we're understanding the relationships between those dots of information within each chunk. Let's look at an example. Memorizing this string of 10 numbers would likely tax your memory. But if we break the string into chunks, we can now see relationships to help us memorize the number. Expert knowledge comes in when we recognize that this is a phone number and more specifically has components that we recognize as a UNM phone number. 2 of the chunks, accounting for 6 digits, are now easily remembered, leaving us with just 4 digits to memorize. You have now just learned the oil's office phone number. It is difficult to generalize how many items or chunks we can manipulate in working memory at one time because it does depend on the task. You may have heard that the magic number was 7, and indeed that's the title of an off-sided paper by George Miller from back in the 1950s. But more recently, the argument has been made for reducing the number to about 4, especially for novice learners. So if we return to Chase and Simon's experiment with chess pieces, we can now see what was going on. The beginners consistently only correctly placed 3 to 5 of the pieces. They were memorizing each piece separately and could only accurately hold memories of about 4 pieces. The more expert players, however, saw relationships between the pieces that were connected to how the game is played. Connections that made it possible to remember chunks of several pieces together, and therefore the correct placement of more individual ones. But when the pieces were randomly placed, there were no obvious relationships and therefore no distinction in the level of knowledge and ability to reproduce it. There is no expert advantage. How one engages with new content also determines how it is organized for forming lasting memories. Listening passively to a lecture has repeatedly been shown to be inferior to the learning that occurs when learners actively engage with the material. Here's a classic example that was based on looking at the learning that was achieved by students between the beginning and end of a semester in first semester college physics, depending on how the course was taught. In a traditional introductory physics course, the professor lectures at the front of the room and frequently shows demonstrations of processes. And we can look at the nature of the learning as a consequence of these kinds of courses by giving the students a pretest before the beginning of the semester on their understanding of the concepts covered in the first course. And on average, they knew about that much. And then quizzing them again at the end on the same assessment and seeing that they learned that much that they hadn't already known, leaving all of that unlearned. However, in other courses taught with similar students that undertook an interactive engagement approach, where the students weren't listening but were conducting small experiments at the desktops in the lecture room, were solving problems with one another, arguing and debating what the outcome of a demonstration would be before it was conducted, etc. On average, there was twice as much learning, and as much, in some of the studies, as 3 times as much, leaving less that was unlearned. In a lecture, most learners are focused on listening and copying the teacher's notes into their notes. And organization of knowledge is dependent largely on how the lecturer organized it, which is why well-organized lectures with objectives, advanced organizers, explicit and visually symbolic representations of concepts are really essential. But the best learning arguably takes place when the learner organizes the knowledge himself or herself, including connections to his or her unique prior knowledge. Is shown here as a student is studying notes from a class. But also, learning with others helps with organization through elaborative explanations and experiences of how others approach the problem, which is why active learning generates greater learning than sitting in a lecture. In fact, it was once noted some time ago that lecturing is that mysterious process by which the contents of the notes of the professor are transferred to the notebook of the student without passing through the mind of either one. And I think we've all been in lectures and training sessions where we've had that feeling. And although most research on the importance of active learning versus lecturing focuses on university learners, the concept is increasingly visible in the training literature as well, and as it should be, because the success of active learning rests in how the brain works, as we'll see when exploring learning theories and neuroscience aspects of learning later. So a slightly longer warm-up video this week, but hopefully one that's insightful to giving you some thoughts about the topic. As you're doing the reading and perhaps looking at some of the optional videos, you might think about how you organize new information and endeavor to study and learn it. How you organize your writing and presentations, including in this course, to aid the learning of your audience. How could you be using advanced organizers? And again, I encourage you to think about maybe using concept maps, not only this week, but in the future. And also think of times when you were a deep learner and times when you were a shallow learner, and what factors determined your different approaches. That's it for this week. Adios.